Hello Math 2 students, the purpose of this video is to teach you all about four-sided shapes, quadrilaterals. What are their names? What are the definition of those quadrilaterals? And most importantly, how can you draw these quadrilaterals perfectly by using your straight edge and your compass? Our first quadrilateral is a parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. If you look at the diagram, notice that the top has one arrow because it's parallel to the bottom, which also has one arrow. And this side has two arrows, and it's parallel to this side that has two arrows. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. The best way to draw a parallelogram is by drawing the diagonals first and then connecting the endpoints of the diagonals to form the perfect parallelogram. Both pairs of opposite sides will be parallel. So the first thing to notice is we need to look at the diagonals and notice that the diagonals do not form a right angle. They're not perpendicular. Don't forget, as I construct the quadrilaterals, you should construct them along with me on your notes. So we're just going to construct the diagonals. We're just going to draw basically an X on our paper, but we're going to make sure that our X is not formed by perpendicular lines. So those are going to be our diagonals. Now what we need to notice about the diagonals is that this one has one mark and this one has one mark. So we're going to take this diagonal and cut off congruent line segments on each side of it. So I'm going to set my pivot point to any distance, set my compass radius to any distance, put my pivot point at the center of my diagonals, and now I've just cut off two congruent line segments just like the ones marked here. Now, the other diagonal is also broken into congruent line segments, but because these have two marks instead of one, it needs to be a different compass radius. So I'm going to make my compass radius a little larger, and then I'm going to do the same thing. I'm going to cut off part of this diagonal, swing it around, and cut it off over here. So these are the diagonals that have one mark in this picture, and these are the diagonals that have two marks. These segments are congruent, and these segments are congruent. Now, if I join the endpoints of these segments, I will have a parallelogram. It'll be a quadrilateral, and both pairs of opposite sides will be parallel. So there it is. I just used the diagonals to make a perfect parallelogram. This side is parallel to this side, and this side is parallel to that side. Our next quadrilateral is a rectangle. A rectangle is a parallelogram. Its top and bottom are parallel, and this side is parallel to that side. But on top of that, it has four right angles. A rectangle is a parallelogram with four right angles. When I construct a rectangle, the first thing I notice is that the diagonals are not perpendicular. So I don't have to start off with the perpendicular bisector construction. I just need to make two intersecting lines that don't form a 90-degree angle. So there I go right there. And then I notice that every segment is congruent. So since every segment is congruent, I'm just going to put my pivot point at the point of intersection, and I'm going to draw a circle. And so I have 1, 2, 3, 4 congruent segments, just like they do. And when I join the endpoints of these 4 congruent segments, I will have a parallelogram that has exactly 4 right angles. So this side is parallel to that side. This side's parallel to that side. And all of my angles are right angles. Our next quadrilateral is a rhombus. A rhombus is also a parallelogram. The opposite sides are parallel. But on top of that, a rhombus is a parallelogram with 4 congruent sides. To construct a rhombus by using its diagonals, the first thing that you need to recognize is this right here. The diagonals of a rhombus are perpendicular. So I'm going to start this construction by drawing a perpendicular bisector. So these are my two diagonals, and these are the two diagonals of the picture that I'm copying. They have a 90-degree angle. I have a 90-degree angle. The next thing that you need to notice about the rhombus is that the diagonal to the left and the diagonal to the right are congruent segments. So I'm just going to use this picture right here because my diagonal to the left and my diagonal to the right are cut off by these equal arcs. So these are congruent segments. And then if I look at the segment above and the segment below, they both have 2 marks. So those are congruent segments. But this arc and this arc already cut off congruent segments above and congruent segments below. So now if I just connect these points of intersection, I will have a perfect rhombus. The opposite sides will be parallel. And all 4 sides will be congruent. Those sides are parallel. These sides are parallel. And they are all congruent sides. So I'm going to put 1 mark here, 1 mark here, 1 mark here, 1 mark here. The next quadrilateral is a square. A square is also a parallelogram. Its opposite sides are parallel. But the definition of a square is it's a parallelogram with 4 congruent sides and 4 right angles. To construct a square, the first thing I notice again, perpendicular diagonals. So I start this construction by using a perpendicular bisector, and that's how I'm going to make sure that I have perpendicular diagonals. So they have perpendicular diagonals, I have perpendicular diagonals. Now on a square, every segment is congruent. So if I put my pivot point here and cut off 4 congruent segments and join those together, I will have a perfect square. Since I need to cut off congruent segments on every side, I'm just going to make a circle . And so now I have 1, 2, 3, 4 congruent segments, and those 4 congruent segments are perpendicular. So now if I connect the points where the circle crosses the diagonal, I will have 4 equal sides and 4 right angles. So that's 90 degrees, that's 90 degrees, that's 90 degrees, that's 90 degrees. All the sides get 1 mark because they're all equal. And a square is a parallelogram. So I can put 1 arrow here, 1 arrow here. I'm going to put 2 arrows here and 2 arrows there. And there's my square. It is a parallelogram with 4 right angles and 4 congruent sides. Our next quadrilateral is a kite. A kite is not a parallelogram. Its opposite sides are not parallel. And the definition of a kite is kind of long. A kite is a quadrilateral that has two pairs of consecutive congruent sides. So these two pairs of sides up here are consecutive congruent sides. A quadrilateral has two pairs of consecutive congruent sides. So these two sides are a pair of consecutive congruent sides, and these two sides are a pair of consecutive congruent sides. But no opposite sides are congruent. So this side over here is not congruent to this side over here. The opposite sides are not congruent. A kite is a quadrilateral that has two pairs of consecutive congruent sides, but opposite sides that are not congruent. To construct a kite, again, the first thing I notice, perpendicular diagonals. So I need to start with the perpendicular bisector construction. So they have perpendicular diagonals, I have perpendicular diagonals. Now on a kite, the left is equal to the right, but above is not equal to below. So the only thing I need to make sure of is that these two are the same, and I already have those cut off, but I need to make sure that this part is not the same as this part. So I'm just going to pick a point right here. And now when I connect all of my points, I will have two pair of consecutive sides that are congruent. So this side's next to this side. Those are consecutive sides and they're congruent. This side is next to that side. Those are consecutive sides and they're congruent. But notice the opposite sides are not congruent. And that is a kite. An isosceles trapezoid is also not a parallelogram. As you can see, the top has an arrow and the bottom has an arrow showing that there is a pair of parallel sides, but both pairs of opposite sides are not parallel because the one on this side and the one on this side, those aren't parallel. So an isosceles trapezoid is a quadrilateral with exactly one pair of parallel sides and one pair of non-parallel sides that are congruent. The parallel sides have arrows on them. That's the top and bottom. And the congruent sides have slashes on them. That's the left side and the right side. When constructing an isosceles trapezoid, the first thing I notice is the diagonals are not perpendicular. So I don't need to do the perpendicular bisector construction. I just need to have two intersecting lines on my paper. Now, on a trapezoid, you need to notice that the top two segments are equal. So I'm going to set my compass at any length, and I'm going to make sure that this top segment and this top segment are the same. So these two segments are the same, just like these two segments are the same. Now I'm going to do the same with the bottom. These have two marks instead of one mark, so they need to be a different size. So I'm going to make my compass just slightly larger. So my radius is a little larger than it was for the first two diagonals. So this segment equals that segment, and this bottom segment equals that bottom segment. When I connect my points, I will have exactly one pair of parallel sides. So this side is parallel to that side. But these non-parallel sides are going to be congruent. So this side is equal to that side.
I hope this video did help you remember the names of all the different quadrilaterals, and I hope you can draw them now by using your compass and straight edge. Remember, pay attention to the diagonals, and the sides will take care of themselves.